So here in this problem, it's given that 9 harmonic means are inserted between two numbers, 2 and 3. We need to verify that for any of the arithmetic means a and the corresponding harmonic mean, the equation a plus 6 over h equals 5 is true. Let us begin. So first we'll suppose that let the harmonic means be h1, h2, h3 all the way up to h9 be the 9 harmonic means inserted between the numbers 2 and 3. Now that would mean that 2, comma h1, h2, h3 all the way up to h9, and then we have the last term, that's 3. These numbers are going to be in harmonic progression. Now, if they are in harmonic progression, then we can say that the reciprocal 1 over 2, 1 over h1, 1 over h2, all the way up to 1 over h9 and 1 over 3. These sequence are going to be in arithmetic progression. Now, if it's in arithmetic progression, then we can suppose that let the common difference be denoted by, it's going to have a common difference, let it be denoted by the letter D. Then we can define the nth term. The nth term of the arithmetic progression, which is given by the first term added to the n minus 1 times the common difference d. Fine. What's the nth term? The nth term is the last term. So that's simply going to be 1 over 3. Then we have a, which is the first term. Our first term, that's 1/2 plus n minus 1. So here n will be, since we have inserted 9 harmonic mean and we also have to include these two. So in fact, there are a total of 9 plus 2, that means 11 terms present. So similarly, in the arithmetic progression also, we have a total of 11 elements present here. So we have 11 minus 1 multiplied to d. So solving for d, we get d equals to negative 1 over 60. Fine. We're going to label this as number 1. So we have obtained the value of d. Now, clearly, if we want to find out the value of 1 over h1, so this is the second term. So all we have to do is take the first term, which is half, and add the common difference d to it. Similarly, if we want to find out the term 1 over h2, which is the third term, this will be half plus d. So all we have to do is take the previous term and add the common difference d to it. So that means we have half plus 2d. So similarly, we can find out 1 over h3. So that's going to be half plus 3d. So if we continue the trend, then we can also define 1 over hi. So this is going to be simply half plus I times d. Now we have already obtained the value of d. The common difference is negative 1 over 60, which means that this will be equals to half minus I over 60. So that's 1 over hi. Now let's multiply throughout with 6. So we have 6 over hi. So that will be equals to 6 over 2 minus I times 6 over 60. So what's 6 over 2? That's 3. And 6 over 60, that's I over 10. So that means 6 over hi. So we have obtained the value, that's 3 minus I over 10. Fine. We're going to keep this aside. Let's label this as equation number 2. Now, let's suppose that a1, now let a1, a2, a3, all the way up to a9 be the 9 arithmetic means. So we are inserting 9 arithmetic means between the number 2 and 3, which means now this would mean that 2 followed by a1, then a2, all the way up to a9, and then the last term is 3. So these sequence is going to be in arithmetic progression. So if it is arithmetic progression, so let us suppose that it's going to have a common difference. So let the common difference be denoted by the letter d in lowercase. So we can find out the nth term. So that's simply a plus n minus 1 times the common difference d. So we can find out the value of d here. So the nth term, that means this is nothing but the last term. So this is our nth term. So that's 3. This is going to be the first term, which has a value of 2 plus n. Since we have 9 arithmetic means inserted between two numbers 2 and 3, so 9 plus 2 is going to be 11. So we have 11 minus 1 times d. So this will be equals to d having a value 1 over 10. Fine. Now we can define a1, which is the second term. That's simply take the previous term and add the common difference d to it. So that means we have 2 plus d. If we want to find out a2, that means take the previous term, which is 2 plus d, and add one common difference to it, we get 2 plus 2d. So if we continue this trend, then we can find out the value of ai. So that's simply 2 plus I times d. So let's substitute the value of our d with 1 over 10. So we have 2 plus 1 over 10. So that's the value of ai. So we are going to label this as number 3. So this is going to be the ith arithmetic mean, or the ith value. Now we have already obtained the value of 6 over hi. So that's 3 minus I over 10. So we have 6 over hi. So from equation number 1, we have obtained that this is equals to 3 minus I over 10. And from equation number 3, this is equation number 2 actually. And from equation number 3, we have defined the value of ai. So that's equals to 2 plus I over 10. So if we add both of them, then we get 6 over hi added to ai. So that's simply going to be 3 added to 2, which is equals to 5. So here negative I over 10 and positive I over 10 cancels out, and this actually proves our problem. So we can in general say that if we do 6 over h and add it to a, the arithmetic mean between the numbers 2 and 3, then this is simply going to be equals to 5, hence proved.